Sure. Hello, everyone. I'll share my screen, I think, to start with, maybe. Here. And hopefully that comes through. There we go. So I'm Rick Marks. I'll just give you a really quick introduction to me, but then I'll talk about some of the tech, the things that I've worked on that I thought people might find interesting. In high school, my family owned a video game store, so that's kind of how I got started with video games. I studied avionics and medieval literature, and then my PhD is in underwater robotics, so kind of all over the place in some ways. But I've always kind of considered myself a programmer. That's what I think of myself as, even though there's no computer science up there. I kind of had the Silicon Valley experience. Right after graduate school, I joined a startup. It got acquired. The startup all the people got laid off that were acquired. And then I became a consultant. So I did a lot of different things in a short amount of time. And then I joined PlayStation R&D, and I stayed there for 19 years. I joined before there was even a network as part of PlayStation, which seems like crazy back then. But they let us pick our PSN IDs before the network even launched, and I picked Player One as mine. That was before Ready Player One came out, so turned out to be a very popular ID. But created the PlayStation Magic Lab and had 3 kids that enjoyed my job at PlayStation just about as much as me, probably. Then I joined Google ATAP for 5 years, and I'll talk a little bit more about that probably at the end. But now I'm at UNC, and I am in the School of Data Science and Society, and I have a joint appointment with computer science. But just got here, and it's exciting new kind of change of career. So I've always had this philosophy that kind of combining the experience and the technology together is where the magic happens. It's not just about either one. And some of my other philosophy things are like to start with why. It's a kind of concept from Simon Sinek that there's a really good video on it that I kind of changed the way I did research after that. I highly recommend it. So I always encourage my team to look at the tech through the applications kind of lens. And then we really focused on creating experiences quickly, like rapidly prototyping the experience, not with all the polish, but just to get an idea of what was important in any given experience. We called that experience engineering. We always called ourselves experience engineers. So a lot of different things we did over the course of 19 years at PlayStation. And then similarly at Google, it's kind of the same philosophy at Google. But yeah, maybe I'll talk about one of them now, which is eye tracking was really something that we got excited about, and it now is in PlayStation VR 2. I wasn't able to get it into the first PlayStation VR, but I'm glad to see that they did put it in the next one. And we started on it before even VR. We started on it just on the desktop, and really one of the kind of Eric Larson worked on this, and this is him in the video. Maybe I'll just show the first video. You don't need the audio, but he's explaining it. Basically, there's a character on the screen, and whatever he looks at on the screen, it's like a shopkeeper, the character. The shopkeeper tries to sell him that item. So it knows like what he's looking at and kind of infers what he's interested in and his intent. So this idea of understanding your intent from knowing what you're looking at is something I feel is really strong, and something kind of missing from modern interfaces. So we pursued it in different ways. One of the ways we pursued it first was in VR, knowing what you're interested in VR. And that same kind of technology is useful for other things too. It's really useful for communication with each other. So, I mean, we use it all the time when we're interacting live, but in VR, we can reproduce a lot of that. Oops, let's see. I think I can get this to play. Yeah. So this is just a character that's being controlled in VR puppeted in VR, but it has eye tracking attached to it. And now you can do this on multiple different headsets. At the time, there was no VR headsets you could do this on, but you can see the eyes are kind of move around a little bit, and it's very subtle, but it just makes the character feel much more alive. And he's looking at his hand right there. That's a very like subtle thing. You can see, oh, I'm interested in my own hand because his eyes kind of narrow in on his hand. Just little subtle things like that we found are very huge, convey huge amounts of information actually. And one of the things in VR we found that it did is it really creates this co-presence loop where when someone else is there with you and they're looking at the same thing you're looking at, pointing at the same things you're pointing at, it really starts to reinforce the idea that these things exist and are real. And so this kind of social presence really reinforces just regular presence. You feel like the world is more real because someone else is also seeing it at the same time. And so we started exploring that more. And we focused on, we can do this. We see this happen when we have people in VR together. Could we make the virtual characters give us that same effect by making them behave more realistically? They would be more believable, which is good, but they'd also reinforce that the world is more believable in general. And so there's lots of other people that worked on this. Or worked on similar concepts, but they weren't looking at it for the same reason. They were just trying to make their game better or something. So we tried to look at it in a more fundamental way. And so we started looking at characters, and there's kind of a combination of how they look, the how of it, but then also like what they're looking at. And so I'll talk about the how in a second, but the what is like, they look at the player a lot. The player's the most important thing kind of in a game experience, but they also look at specific things about the player. They look at your movement maybe, or if you're pointing at something, they might look at what you're pointing at. If you're just looking in some direction, they might be interested in what the thing you're looking at is. And you can kind of hold their attention. If you do something, maybe they'll stay looking at you. Similarly, if there's a movement or a sound in the environment, they might turn and look at that, or they might be interested in that. And then one of the things that's interesting is things that are closer matter a lot more to people in general. So modeling that behavior is good. And then we picked a character that looks like kind of like a dog or a pet, not particularly human, because actually just dogs can model all this behavior. You don't have to be super intelligent to have any of this behavior. So, and if there's other characters, they might be interested in them as well. And they might be interested in what they're looking at or what they're interested in. So it kind of extends beyond just the player. And so I mentioned also how they look is really important. And there's some pretty easy rules you can follow. Like basically, people tend to track objects with their eyes when something's moving. So if you make the character track, these virtual characters track something with their eyes, and then they turn their head to keep their eyes in a comfortable position so that you don't want your eyes to go really strange. That most people don't just only use their eyes, they start to turn their head at some point. And then you turn your body based on your head. So it's kind of like this coordinated look where it starts with your eyes, and the eyes move the fastest, and then your head moves to keep up, and then your body. So you also only can see the things that are in your field of view. And blinking is also another very important thing to make something believable. So I'll just show you a quick video of this. So the characters are looking at me. I'm in VR, pretend. It's better to see this demo live, but can't do that very easily this way. So I'm looking around. They look around randomly. If I look at something, they might now be looking at that thing I was looking at. If I'm looking at the horse, the rocking horse, right? So they look back at it. There was just a loud noise. We don't have audio, but the train made a noise, so they all turned and looked at the audio, or the train, sorry. If I point up, you can see they look up at the ceiling. So you kind of they just feel like they're there with you in the room, and it starts to feel like the whole experience is very real. And there's more to it. You can point at objects and they'll go and get them for you. And there's a lot more things we could do with that. But we took that actually same thing into AR. We just added cameras onto the PlayStation VR and made a real crude AR system or MR system. And so you can see we just did the exact same thing. There's a character now. We decided the cameras we had weren't very good, so we decided to render everything in a more like cartoony way. So it was all self-consistent. The characters would look cartoony, and also the world would look cartoony. Otherwise, it looked like computer graphics mixed with video, which is not what we wanted. So here's just a quick short thing of them. Here's a video of me walking in, so they turn and look because there's motion, and we can detect motion in the video too with simple computer vision kind of techniques. So yeah, and then we extended this to make them even more believable and give them some agency, so they could actually affect change in the real world. And this is where we kind of thought this is really where AR is interesting. So the characters, I'll just play this video while I'm talking. So the character, you can point it like a light, and the character will go over and actually just flip on the light. And so it's like a IoT light, a smart light. So of course we're really sending a signal to the light, but it looks like the character is turning on the light. And we had a remote controlled car in the room, real one, and he could pick up a virtual PlayStation controller and drive the car around. So in the real world, and then just going crazy with this. The crossover between real and virtual was kind of fun to play with. So here he's going over and he's turning on a virtual television set. I'm sorry, real television set. And on the screen is a bunch of other characters like him. It's popular at the time. So he started dancing to the music. And one of the other characters comes forward in the TV and also starts to kind of looking out the TV, and then comes out of the TV. That's the point. So now that character, is in the world too. Anyway, so this idea of like crossing over between the real and virtual world, and also this idea of like how important spatial information is. The characters are really the only reason we believe they exist is because they're spatially behaving correctly, and because they can affect change in the real world. And it made me think. So when I joined Google, I was really interested in considering this more, and I was focused on the idea of giving people more agency to interact with computers, not necessarily like getting rid of tasks that they do, but giving them the ability to do more, not less, actually. So one of the first projects was a spatial remote control, where you could actually point at devices and turn them on and off, or drag and drop between devices. You could point at music and drag and drop it to a light, for example, and the light would flash to the music or something like that. You could do other things. You could group devices by circling them. You can imagine like drawing like an area on the floor, like kind of pointing to an area on the floor for a robot vacuum to go vacuum up this like little section of the room or something. So things like that. And then we extended that to Fitbit, where you could actually do it with just a Fitbit, not a remote control. Just the pointing technology for that. I can't talk about too much, but we could know what you were pointing at. And then we had some like kind of gestural detection based on like tapping and things. And continuing on the gestural side, we also were exploring other kinds of more elaborate gestures with EMG sensors in the wristband. And we had one kind of interesting demo where we called it Magic Watch. Basically with EMG, you can kind of know what configuration your fingers are in. So you could look at your watch and it would show you a different thing based on the different configuration your fingers are in. So if you're pointing one finger out, it might show you the time, but if you had two fingers pointed out, it would show you maybe your steps. So having it show you different things just that way. And I still believe now, like that's the end of my talk, by the way. I still believe now that there's this amazing stuff happening with text inference and ChatGPT and things like that are really amazing, but we're still missing a lot of kind of contextual information that we share with each other all the time, but computers have no idea about really. So trying to give computing systems more of that context, I think, is still a very interesting idea and one I'm interested in. And that's it. Thank you.
All right. Thank you so much, Dr. Marks, for sharing your presentation with us. And so before we move on to the next stage of this event, I just want to let you guys know that the second stage will be a Q&A. And for the Q&A, you're allowed to present Dr. Marks with any question that you might have. And before we do that, we're going to ask Dr. Marks with the questions you already submitted beforehand and some questions that our officers submitted as well. And so given that this event is being recorded, add an asterisk in your message if you're comfortable with being on camera, and then we'll unmute you and you can ask Dr. Marks directly. And if you prefer that we ask it on your behalf, just type it in the messages window on Zoom without the asterisk, and we will ask him on your behalf. And so let's get started on the Q&A.
Okay, so some of the questions that our members asked were, can you share some of the most exciting developments in the AR, VR field that you've been involved in or have observed through your work experience?
Yeah, sure. I was doing that kind of stuff for a long time, so I saw a long progression of technology change. At the beginning, we focused on AR actually, but it was kind of a different AR. It was like AR on a television set. So we made EyeToy. And with EyeToy, you start with a video, and we tried to kind of add the game around you in the video. So that was the idea. Moved on to like PlayStation Move, and that was a little bit different. We thought, okay, we wanted to really focus on more of a virtual experience, but we want to let you kind of reach into the virtual experience and interact with what's there. So it's kind of the beginnings of VR, but still, again, through a television set interface. So, but you really felt like you could reach into the scene and do things. Then VR came, and it was really exciting to be a part of this current wave of VR. There's been multiple waves of VR in history, but we're still kind of in the current wave, which started a while back. But with PlayStation VR, we got to work on the technology, but we also got to meet all the other teams from the other companies, which is really very fun, I thought, and getting to know a lot of the technologists. And we shared a lot of information because we really believe that for VR to get popular, multiple companies would have to be doing it. And if any one of them was making a bad experience, it would hurt the whole industry overall. So we did share a lot of information. So I guess that's a lot of different things, but
during your time at PlayStation, could you please share some insights into your challenges while developing these technologies and these lessons you learned from those experiences?
Sure. I think the biggest lesson I learned, luckily early in my career, was to appreciate that research and product development have very different challenges and different things that they're focused on. And as a researcher, it's very easy, I learned, to think, I've seen it happen many times now, where researchers think they can just throw their research over the fence and they should just turn it into a product. And that's not the way things happen, really. It's a lot more challenging than that. And a lot of times things that work in the lab don't work very well in the real world. So one of the best things that happened early for me was I got sent to England for 3 months to transfer my technology over to a game team. And I sat right next to the game team, got to know the game team well, got to see the struggles that they went through to try to make things work. And I gained a very strong appreciation that it's hard to turn technology into product. So appreciating that, I think, is important, and understanding the challenges. So I guess products have a lot of real constraints. You can't do everything you want to do.
The third question was, as the director and the project lead for Google ATAP, you explored interaction approaches for ambient computing environments. Can you tell us about one particular innovative approach you worked on or found fascinating?
Yeah, I think I mentioned already, maybe the pointing was probably the thing that we focused on most, spatial interactions, and just trying to convey spatial information into a computing system. So a few different things that we worked on in that space, but definitely that was the biggest focus we had. And we saw just if you can make the interactions. I guess one of the things that we discovered is in communication with each other, we use pronouns all the time, and pronouns are referring to something that often I'm looking at it or pointing at it, and that just can't happen with computers the same way. So the communication with computers, if you want to talk, for example, is very stilted. It's very, like, you have to be very specific all the time because you don't get to use pronouns. So just that alone makes the interaction so much more natural. So we added a thing to the assistant, so you could ask the assistant questions, but it would know what you're pointed at. So just that one thing. And we combined it with Google Lens. So you could, like, point at, let's say, a Coke can, and you just say, how many calories in that? And it would know how to answer that because it knows what you're pointed at and knows what you're interested in. So that little kind of thing just makes the interaction much more believable. Or, sorry, much more natural.
Awesome. So we just got another question in. It was, have you experimented with trying to detect and display emotion in AR or VR?
I have not done that other than, like, with the character, we made the character have some small reactions, but it wasn't very human-like, so it's not like, I think, maybe what the person's asking. I know that a lot of the modern VR systems are starting to put cameras on the inside so they can detect emotion and detect facial expressions. And so, of course, you could then render those things in a avatar or something, but I haven't really done much with emotion, no.
Awesome. Thank you.
Another question we got asked was, with 100 plus patents to your name, can you tell us about any that you find particularly significant or one that represents a turning point in your career?
Yeah, patents are an interesting thing. I mean, I didn't expect I would have a lot of patents when I started. I was very idealistic and I did not believe in patents very much. Actually, the first set of patents, like, there was, like, the first 2 patents. One of them I refused to sign. My manager ordered me to sign it because I did not want to sign it because I thought it was an obvious piece of technology and I didn't think that should be patented. But as it turned out, I ended up doing lots of patents. And one of the things that happened early on was the head of the legal department said, patents are what allow us to do business. We want to move into a new technology area. We can't do that if we don't have some protection about the area we're working in. So we don't intend to use them offensively. And I think it's important. I felt very good that I worked at a company that didn't want to use them in an offensive way. And you have to trust your company to some degree. And they never have, as far as I know, actually. So just letting our company be able to move into new technology areas, I felt was important. And I heard a really good story. So to pick a particular patent or area of patents, when we were working on VR, I went and visited Valve, and Valve made, with HTC, they made the Vive, and they were working on tracking, and they found all of our patents about tracking. And so they're like, well, we can't do it that way because they have all that's patented. So actually they innovated and they made the lighthouse, and the lighthouse system works very differently. It's very good, very accurate, but completely different than how we did it. And basically, because our patents existed, it forced them to innovate in a new way. And I think it benefited VR in general, which is, I think, kind of what it's intended to do, the patent system. It doesn't always do that, but it worked in that case.
How do you see the role of neural networks and deep learning evolving in the context of AR, VR applications?
That's a big topic, but maybe I guess, I mean, I talked a little bit about context, and I think deep learning and things like that are really good at taking information and understanding it. So if you can feed it more context, I think you could use techniques like neural nets and deep learning to understand the information and make use of it. Another area I'm particularly interested in is generative AI and VR. The idea of creating worlds dynamically or generatively, so generating worlds as you go through them. So maybe and right now, most of the worlds are authored and made by artists, and instead you could make that so the artist still has some input, but they don't necessarily draw every single pixel in advance. And so you could have kind of replayability and different kinds of constraints that the artist puts on the world, but it's being generated by generative AI. So that's an area of research I think is interesting. but it's lots
What
of
are
different
the,
things.
oh, sorry.
No, it's okay.
What are the technological challenges in merging real-time sensor data with AR, VR visuals to create truly immersive, context-aware experiences?
That's funny because I'm basically teaching an entire class about that right now. So I'm teaching Intro to VR, and we talk about all the different technologies that go into VR. And there's a lot. I mean, VR is kind of a lot of different things all mixed together. It's got optics and display and rendering and tracking, lots of different things. So there's a lot. Let's see. Well, I guess you mentioned like contextual immersive, and I really feel like eye tracking is one that is important and missing from kind of most headsets right now. Still, it's coming in some, but I was disappointed Oculus or is not. I guess Quest 3 doesn't have eye tracking. That was I feel like a setback to eye tracking, but because it's just about to come out, and I really feel like just more sensing, giving the ability to know what you want more is what helps. So I'm a big person. I'm a big interaction and sensing person. So I guess that's my answer.
Can you discuss the technological challenges and solutions in developing intuitive and natural user interfaces for AR, VR, especially when transitioning from traditional 2D interfaces?
Yeah, going from 2D to 3D is a big step. My students right now are tired of transforms and understanding how to like change from one space to another space in 3D. It's complicated, and in 2D it's just like a shift left or right and a little one rotation, but it gets much more complicated in 3D. So keeping track of that's hard, and the kind of that carries over into interfaces. There's a lot of different degrees of freedom that come up in interfaces. So people move in a lot more complicated ways, I think, in 3D, and there's more variability in how they move in 3D than there is in 2D. But I think also, I mean, I got to meet the person who invented the mouse, Doug Engelbart. That was a highlight of one of my highlights of my career. And the mouse is so taken for granted. But back in the day when the mouse was introduced, people didn't think they needed an input like that, a spatial input. They thought they could do everything with text or keyboard. So I think we're in a similar situation now in 3D. People, don't necessarily think they need the spatial information for a lot of things. We do a lot of things instead. We switch it to 2D and do everything 2D. But I really believe we'll probably need something that gives us, like the mouse. What one thing did the mouse enable? There's not one thing that it enabled, but it enabled like lots of interaction with many things in a little bit different way. And I think that's what we're kind of missing maybe. So.
That sounds great. And then another question that we had was, with the increasing computational demands of AR and VR, how do you envision the balance between cloud computing and edge computing in future systems?
Yeah, that's funny because so I was in the group I was in at Google. There was the edge processors were developed in the hardware group that I was in, and so we talked a lot about whether you do stuff in the cloud or in the edge. At the edge, for example. So I always thought that VR would be very hard to do in the cloud because it's so dependent on latency and speed. But I got to try a cloud-based VR system that was really, really impressive. Most of the rendering was done in the cloud, and there is a component at the edge that made it so that it updated what was on the display to match your head motion. But the majority of the rendering was in the cloud, and I was surprised that you could do that so well. So I have a lot more optimism that cloud could be a part of VR, but it's tricky because it really, you can't. It's not like other things where you can just send it late and buffers or something. That's okay. Your head's in there, and you don't want anything like that to ever happen to somebody. So when things freeze up, it's not good. So I still think that it's going to be a lot of stuff, a lot of processing happening on the edge, but Yeah, maybe generation. We know you can do some of the generative stuff I mentioned before, generating worlds as you go through VR. You could do that in the cloud and then send those worlds over just before you get to them, or send those parts of the world over just before you get there. I think that's a neat area to explore.
That sounds great. So given the rise of ambient computing, how do you see the technical evolution of context-aware systems that can seamlessly integrate into our daily lives?
I think I keep going back to the same thing, but I really believe like spatial context is the part that we're missing. And like, just knowing what I'm looking at, eye tracking, that too, that's another spatial component. Where my eyes are pointed, where my head's pointed is a big part of what you think as a person, what you think I'm interested in. And computing systems just need to have more of that to understand people better, I think. So I would say that's still what I think is the most important part.
For sure. Yeah, moving on, we just got another question from our audience about future applications of VR and AR in communication. So Lorenzo, do you want to unmute?
Hello. So what I wrote down was just, in your opinion, do you see VR or even AR becoming a staple of communication between people, similar to how email and texting have become commonplace? And do you see this happening in, I guess, anytime soon or even just in the next few years?
That's a great question. And I guess I would have thought it would have happened more than it has. And I think that like with COVID, it like missed probably a time when it should have made some strides in that area. Zoom, where we are now, definitely like exploded during that time, and seems like maybe it's because we really miss real person interaction, and I can really see the person I miss this way. But for example, with my son, I'm in California, or he's in California now, and I'm in North Carolina. We meet over VR in order to just communicate. So we play a game. We play Demio, which is a fun multiplayer game, and we talk, and I can kind of see him pointing at stuff, and I do that instead of Zoom with him all the time. Now, most other people I don't do that with, but that's how we prefer to interact. And I do feel like he's present with me. I feel like we can communicate just as well. I know him really well, so I know probably the expression that's on his face when he's saying something. But I believe that co-presence, when it's done well, is very powerful and just as good as video. But it's not. It doesn't seem to be that everyone. I mean, I guess maybe the biggest problem is the encumbrance of putting all the gear on. Still seems like it's kind of prohibitive, where you can just click on the Zoom button and it's there. So as that gets easier and easier, maybe I believe that will become more. And I know some people already do it, and maybe not VR and AR, but in video games, a lot of people only talk to each other through video games, and they're playing some social experience that way. And that's the only way they communicate. Feels like VR should be an extension of that, but it just hasn't quite permeated, I think, the mainstream yet.
Got it. Thank you for answering my question.
Yeah, I'm not sure if I wish I could give you more. I'm pretty optimistic on it, but it hasn't happened as fast as I thought it would.
So another topic that I know a lot of us officers and board members were really interested in is also VR and AR. So since Apple has released very recently too, one of the best VR and AR headsets that we've ever seen, what do you think the future of VR and AR would look like? Will there be other companies that are going to be try to compete that are going to try to compete with Apple, or?
Yeah, actually, I'll answer that right after. I'll add one more thing to the other thing, and Apple has kind of triggered it. Is one of the reasons I think VR is tricky for communication is it does cut you off from the rest of the real world during that time. So if you can have it so that you're not completely isolated and not know and feel vulnerable in the real world, then I think it could change things. Apple has been focusing on that problem a little bit. Now, I'm proud to say that two of my old teammates, they work on that team at Apple. So one of them left Sony around the same time I left Sony and joined Apple. And then one of my team at Google, when we left, she joined Apple and is there now. So I think they're doing amazing things. Their headset is really good. The term best is not easy to use for everything. Best means different things to different people. I mean, it's maybe got amazing tracking and amazing resolution and things, but it's very expensive and not everyone can experience those things. It's like saying, as if you look at automobiles, what's the best automobile? Depends. There's a lot of different factors that go into what's best. So it's hard to make the hardware for VR. It's not everyone. There's not going to be a lot of small companies that can compete with the bigger companies at making consumer level hardware, at least. So I don't think you'll see tons of companies making them, but I think there'll be a range always. And it's good to see Apple making one. I don't think it's like over now or something like that, that's for sure. But usually when this happens, it pushes every time somebody, makes a better one in some way, other companies have to catch up. So I think it's good for the market, actually.
Hey, Dr. Marks, thank you so much for that. So you mentioned that with like the current price that Apple's headset isn't really for consumers, and really with the $3,000 plus price tag, it's mostly for developers. But do you think that with the increase in competition in the upcoming years with Apple's steadfast progress, it'll lead to like a scenario where they're widespreadly available for consumers as well? Or do you think it'll just be available for developers for the foreseeable future?
I don't think Apple's doing it in order to just have it be for developers, that's for sure. Like that, their plan is to eventually make it mainstream. They're definitely a mass market company. That's their focus. So I don't know how that will manifest, and how long it will take. But they make quality stuff and they try to get it to be available to as many people as they can. They're still a premium brand most of the time. They're almost always at the premium level. So it's not like they're going to compromise in every way to get it into everyone's hands. But yeah, I think their focus is definitely to make it so more people can have it than can have it at the price it is now.
Great, thank you so much for that.
So the rest of these questions are a little bit more like student oriented. And I know that you shared that some people had originally reached out to you for like research positions and stuff like that. So in accordance with that, can you share any advice for aspiring researchers and innovators in the field of like AR and VR, machine learning, and like other context-aware systems?
Yeah, I think now is like an amazing time in this area, especially on the AI front. AI is everywhere. If you turn on the TV, it's talked about all the time. Things are moving fast. That's also a fun time to be a part of things like that. But it's also amazing that you can get access to a lot of things right now, and both in graphics and AI. It's easy to download Unity or Unreal Engine and start doing something, and it's easy to start playing with ChatGPT or OpenAI and start even trying to do things on your own with making AI models. I guess the thing I found that was the most important part of my career is when I was young, I just tried making stuff all the time. And sometimes I just made stuff that already, like, I guess I still do. Like, I make something that I already know. It's already been made before, but I want to learn how to make that thing and learn the tools. And then I can maybe make something new after that. When I first got a computer, I didn't have a way to store. I didn't have the storage device, only the computer part. So like every night I have to turn the computer off and I lose everything. So every day I'd write the game Breakout and I'd write it like a different way each time, sideways, upside down, different kinds of graphics. And I just kind of learned all the different parts of how to do graphics on the computer I owned. And I think now I do something similar every time I come to a new language or a new platform. I take something I know the rules for and try to implement it using those new tools just to learn how it works. And so like I recommend if somebody wants to learn graphics, download Unity and make some game that already exists that you know how it should look and see if you can mimic it. And then once you can mimic something like that, then you can maybe make something new on your own. That's what I think. But prototyping stuff, trying stuff is the best thing I can recommend for research.
So yeah, so I know you mentioned like how early you mentioned like ChatGPT and stuff like that. So we actually have a question like, or one of our final questions is actually regarding AI and its like use in education. How do you think, like, what do you believe are going to be the concerns with integrating AI into education, and how do you think we can maybe combat this?
Yeah, actually, there's a that's a topic. I mean, I'm at UNC now, and so it's my job is to educate, and it's a very hot topic around here, and especially in the School of Data Science, which I'm in. So there's a great talk I saw recently by a professor at Harvard. His name is, I have it written down here. It's Kareem Lakhani, and he actually goes and he says it's an existential moment for education. We have to figure out this. It's really important. And at like an hour into the video, the whole talk is quite good, but like a little bit more than an hour into the video, he actually asked ChatGPT what it thinks about how this is going to affect education. And it comes up with very good answers about like the pros and the cons of using generative AI in education. I think the cons, there's a lot of pros. Like it's a powerful tool. I think of it like a tool, and to have a tool that you don't use doesn't make very much sense to me. When I was young, calculators were a very similar conversation. Actually, in school, people did not think calculators should be allowed, and everyone said people will get over reliant on calculators and they won't be able to do any basic math. And I think that didn't prove to be true for most. Always right. So like a calculator, when you type something in, it comes back with the right answer for whatever you asked all the time. Whereas with generative AI, it's a little bit different. That just means you have to treat it slightly differently. So I don't think it means we shouldn't use it at all. It just means you have to. There's other things that we use that are not perfect either. They're not precise. When we go to the web and look up something or do some research, you can get false information. So you have to be careful about how you use it. But I think, yeah, I think there's dangers, but I think the pros are there for sure. Also, I guess I answered about research, but one of the topics that I really feel strongly about in teaching now is I think like math and physics are really important fundamental things to know for everything, and especially for computer science people, maybe. A lot of times it's easy to think that those things don't directly apply to anything you're going to work on. And maybe they don't directly apply, but they kind of give this like layer of intuition about things and kind of a fundamental understanding of how the world works that's hard to replace just with kind of more applied knowledge where you just know, I type this command in and this happens. That's useful, but it isn't necessarily like fundamental. And so it doesn't extrapolate very well. So I really feel like if you're going to study stuff, I'm very lucky that I had an engineering background as well as being interested in computer science. So I think that's helped out a lot. Sorry, lots of words.
Awesome. Thank you so much once again, Dr. Marks, for joining us at SAILea today for this guest speaker event. We really appreciate you taking the time to answer all these student-led questions and share with us your experiences and knowledge. And again, to anyone that's looking to go to UNC-Chapel Hill, you have your professor right here, and maybe like not freshman or sophomore year, but eventually you should definitely take Dr. Marks's course if you want to really go into virtual reality. And again, I think this event has shown that he is the perfect person for that. Okay, and before we wrap up today's event, I also want to share with you guys a few things that SAILea will be doing in the upcoming weeks. Okay, so SAILea will be launching live courses on the principles of machine learning and deep learning. And that will be happening around the second week of October, maybe around the first week, but we will send out a sign-up sheet for you guys to fill out to really determine what times are best suited. And additionally, be on the lookout for more speaker events and competitions that we'll be hosting throughout the year, because there will be more. This is a really good one to get us started with Dr. Marks, but there will be more competitions throughout the end of the year. So definitely stay in touch for that. And to stay updated, definitely follow us on Instagram at the Scholastic AI League. And once again, thank you all so much here for joining us today. And I hope you all have a great rest of your day. Thank you.